Hello students. So all these elements, like 118 elements are there. So all these elements, do you think all these are they available freely in the nature? The answer is no. These elements do not available in the nature freely. Then how do they available? They are always available in the nature in the compound form. For example, let's take hydrogen atom. What is the symbol of hydrogen element? H. So do you think hydrogen atom exists in the nature freely like hydrogen atom? No. Hydrogen combines with another hydrogen to form hydrogen gas. Why it combines with another hydrogen only? That depends upon the valency that we'll discuss in this video. So as well as, does it combine only with other hydrogen? No, it combines with oxygen also to form water. If it combines with chlorine, it forms hydrochloric acid. So it can always available in the nature in the combined form only. That combined form is because of chemical bonding. Why this chemical bonding takes place? What are the factors? Everything we'll discuss in this video. So first of all, what's the first point? All these elements, all the atoms do not available in the nature in the free state like atom. They are always available in the combined form only. So that nature where the force which holds two or more atoms together is called as chemical bonding. So what are the types of chemical bondings and what are the factors influences chemical bonding? Everything we'll discuss in this chapter in this video. So to start with students, so does it mean all the elements are available in the nature in the compound form, or any elements possible do they exist in the free state? The answer is yes, there are few set of elements which are available in the free state. They are called as noble gases. Yes or no? Even in the periodic table chapter, previous chapter, we discussed about the noble gas family, 18th group elements. So what's the meaning of noble gases, students? Noble gases means the elements which are completely unreactive are called as noble gases, right? So what is the nature of these elements? They do not react at all. They are chemically unreactive. So what makes them chemically unreactive? That we'll discuss. See, listen here. So let us check the configurations. So remember, any chemical bondings, any chemical reactivities are happening because of which subatomic particle? Because of electrons only. So definitely we need to write the configuration of electrons, yes or no, in order to find the reactivity. So these are all the electronic configurations of noble gases. What are noble gases? Helium, neon, argon, krypton, xenon, radon. Radon is radioactive. So helium, what is the configuration of helium, students? Its atomic number is 2. Helium configuration is 2. And neon, what is the configuration of neon? Atomic number 10. What is the configuration? 2, 8. Argon, look at the configuration 2, 8, 8. Krypton 2, 8, 18, 8. And xenon. So all these are the configurations of noble gases. What is the common thing in all these noble gases, students? Like, what is the common thing in all these noble gases? Once check, the common thing in all these noble gases is they all have how many electrons in their last shell? They all have 8 electrons in their valency shell. Yes or no? This last shell is called as valency shell. This is the reason for stability. Sir, why only 8 electrons? What is happening there? Valency shell, students, if you want to define in terms of shells and subshells, S subshell can accommodate maximum 2 electrons. P subshell maximum can accommodate 6 electrons. 2 plus 6 how much? 8 electrons. So that means if S subshell and P subshell are completely filled, that gives stability for the elements. So for the noble gases, S subshells and P subshells are completely filled, which are in the valency shell. Remember, valency shell means what? The last shell. What about helium? Helium is an exception. Why? Because in helium, the valence electrons are present in the first shell. First shell, does it have P subshell? No, only S subshell. It can accommodate 2 electrons, and there are 2 electrons completely filled or not. That's why this configuration is called as duplet configuration, students. Helium configuration is called as duplet configuration. Remaining all the noble gases configurations are called as octet configuration. Why they are called as octet configuration? Why? Because there are 8 electrons in their valency shell. So all these configurations are called as octet. So what understood? Got the clarity? Why these set of elements, these group of elements, 18th group elements are chemically unreactive? Why? Because they already have 8 electrons present in their valence shell. What is the speciality about this 8? S subshell, P subshell, S subshell maximum 2, P subshell maximum 6, 2 plus 6, 8. So filling of S and P giving the stability. Why? Because they are the least energy orbital comparatively to the other D and F orbital. So This gives the stability, this gives the unreactivity. Stability means unreactivity. Students, stability means what? Unreactivity or least reactivity. So these set of elements, why they are stable, why they are unreactive? They already have 8 electrons. And now the main point, why other elements are reacting? They want to get 8 electrons. Sir, no. They already have 8 electrons, they are unreactive. Why other elements are reacting? Why? Because they want to achieve this 8 electron configurations. How do they achieve? That we'll discuss in the coming slides. Understood? So the noble gases except helium, they already have 8 electrons. Remaining other elements, how many electrons do they have? Let us take first group elements. First group elements configurations, hydrogen 1s1, lithium 2s1, sodium 3s1, potassium 4s1, 5s1, 6s1, all they have 1 electron in their valence shell. Yes or no? It has how many electrons? 1 electron. Look at the second group elements, beryllium 2s2, 3s2, 4s2, 5s2, 6s2, all they have 2 electrons. Look at the 13th group elements, boron family. What is the configuration? 2s2, 2p1, 3s2, 3p1, 4s2, 4p1. They all have 3 electrons. Next group 4 electrons. Next group 5 electrons. Next group 7 electrons. 6 electrons. Next 7 electrons. Last noble gas 8 electrons. That means remaining all the elements, they have how many electrons in their valence shell, students? They have 1 to 7 electrons, depends upon their group. Got the clarity? And always they want to achieve which configuration? Either duplet configuration or octet configuration. Which elements can get duplet configuration? The elements which are near to the hydrogen atomic number. Yes or no? Like lithium, beryllium, hydrogen. So duplet configuration of valence shell makes an element inactive. What is the meaning of inactivity? Chemically unreactivity. That is what they want, every element. So octet configuration of valence shell makes an element inactive. So all these elements want to achieve which electron configuration? Noble gas configuration simply. How many types are there? 2 types. One is duplet for helium only and the remaining are octet. Oct means 8. So with the exceptions of the noble gases, atoms of all the elements have how many? Students, this is the main point. 1 to 7 valence electrons in their outermost shell, in their electronic configuration of outermost shell. This element is incomplete. Yes or no? For example, first group elements, how many electrons? 1. More, how many they need? More, 7. Got the clarity? Second group elements, how many valence electrons are there? 2. More, how many? More, 6 they need. 16th group elements, how many valence electrons are there? 6. More, how many it needs? More, 2. Got the clarity? All these elements are reacting. Why? In order to get that 8 electronic configurations only. Students, got the clarity? So that's why they are reacting, so that they attain the duplet or octet configuration. Then how do they get this configuration? Okay, they already have 1 to 7 electrons. They want to achieve that configuration, but how do they get that configuration? Chemical reactions takes place by 3 ways, students. Either by losing electrons, by gaining electrons, or by sharing electrons. That's what the chemical bonding started. Sir, no. How do the elements get 8 electronic configurations in their valence shell? Either by losing electrons or gaining electrons. Second one is by sharing electrons. So what are these sharing? What are the details? We'll discuss in all the types of chemical bonds in this chapter. So first of all, you got the idea why these elements are reacting in order to achieve noble gas configuration. We have an example here. Consider sodium. What is the configuration of sodium, students? 2, 8, 1. Yes, sir. 1s2, 2s2, 2p6, 3s1. How many electrons are present in the valence shell? This is the valence shell. How many electrons? Only 1 electron. More, how many it needs? More, 7 it needs. In order to octet configuration, yes, sir? No, students, right? Answer. Gaining 7 is better or losing 1 is better? Gaining 7 is better, losing 1 is better. So it lost 1 electron. These elements are very smart. That's what we are also made up of, yes or no? So for sodium, how many electrons it need to lose? It loses 1 electron. What happens after losing electrons? Now the valence shell becomes this second shell. Yes or no? Look at how many electrons now? 8 electrons. After losing 1 electron, now this number 8 becomes a valence shell. Yes or no? The electrons present in the valence shell becomes 8. It gets octet configuration or not. Ultimately, all these elements want to achieve octet configurations either by losing or gaining or sharing. So look at the chlorine example. Chlorine, the configuration is 2, 8, 7. In this configuration, what is the valence shell? How many electrons are there in the valence shell? 7. More, how many it needs? You answer 1. Losing 7 also it will get octet configuration. Which is better? Losing 7 is better or gaining 1 is better? This time gaining 1 is better. So this electron will be gained by chlorine. Understood? Got the clarity? So that's why some elements loses electrons, some elements gains electrons, and some shares electrons. Ultimately, what is their goal? They want to get stability. Stability means what? Noble gas configurations. Right? Got the clarity? And look at here together. After sodium loses an electron, which is gained by the chlorine atom. So sodium electron gained by the chlorine atom. Yes or no? The result is sodium becomes which ion, students? Na plus ion. Yes or no? Sodium after losing one electron it becomes a cation, and chlorine after gaining electrons it becomes an anion. Does it? And so sodium after becoming sodium ion finished? Chemical bonding is done? No. Chlorine after becomes chloride ion done? Finished? No. After becoming sodium ions and chloride ions, they combine, they attract with each other. Why? Because they have a positive charge and they have a negative charge, and they become a compound called as, students, NaCl, which is called as sodium chloride. Now this compound is stable as well as neutral also. Understood? So that's why these reactivities are different for different elements. Sodium is losing one electron. Does it mean all the elements loses one electron only? No. Look at the second group elements. Beryllium, magnesium, calcium, strontium, these elements. They have 2 electrons. Now they need more 6. Gaining 6 is better or losing 2 is better? Losing 2. So what is their valency? 2. Sodium valency, it is losing 1. What is its valency? 1. Yes or no? 13th group elements. There are 3 electrons. More 5 it needs. Gaining 5 is better or losing 3 is better? Losing 3. 14th group elements, they can share 4 electrons. They cannot lose 4, they cannot gain. Ultimately, they want 4. They have 4, they need 4. So they share 4. Carbon family. Of course, down the group, there are metals can lose 4 electrons. Next, 15th group elements, they have 5 electrons. Now answer, 15th group elements, nitrogen, it has already 5 electrons. So what is the criteria here for nitrogen? Already 5 are there. More how many it needs to fulfill octet configuration? More 3. So losing 5 is better or gaining 3 is better? This time gaining 3 is better. Its valency is 3. Yes sir, after gaining it will get a minus 3 charge. Oxygen, 6 electrons are there. Losing 6 is better or gaining 2? Gaining 2 is better. 17th group elements, chlorine family, like halogens. Yes or no? So losing 7 or gaining 1? Gaining 1. Understood? So based on their configurations only, we have elements with different valencies. Understood? So next we have the stability is also related to the energy. That means if there is more energy, the particular element or compound is less stable. Remember, more is the energy, less is the stability. Less is the energy, more is the stability. Understood? More is the energy, less stability. Less energy, more stability. So while the chemical bond formations in general, these elements, they lose electron, they lose a particular amount of energy in order to form the most stable state. In order to get the most stable state, energy is also one of the main reason. Not only these configurations, in order to get into the most stable form, they should lose some energy. So the reactants lose energy and the resulting products has less energy. As the product has less energy, it is more stable. During a chemical reaction, stability is also achieved by the lowering the energies also. Right? Got the clarity? So next, octet rule. So to explain the reactivity of all these elements, in the first slide which I explained, we have a rule, students. The rule is called as octet rule. Oct means 8. So every element in the periodic table, most S block and P block elements, representative elements, they want to achieve stability in order to get how many electrons? 8 electrons in their valency shell. The tendency of an element to get 8 electrons in its valency shell is called as octet rule. Why only 8 electrons? We already discussed. Yes sir, got the clarity, students? So if they want to acquire 2 electrons, which with the elements which are nearest to the helium, so that configuration is which configuration? Duplet configuration, right? So generally is octet configurations. Next, Lewis dot symbols. Okay, these are all the chemical bonds. Simply we are saying the chemical bondings. Then how I want to represent the bonding. How to represent? The answer is Lewis dot symbols. Very simple. The symbol of an element surrounded by dots. What are Lewis dot symbols? The symbol of an element surrounded by dots, and the dots indicates valence electrons. Simple. The symbol of an element surrounded by dots or stars, and these dots or stars indicates number of valence electrons. Hydrogen, how many electrons are there? 1. So 1 dot. Sir, where to place this dot? Anywhere surrounding that element. So while representing the particular chemical bonding, you have to represent according to the convenient way of in the bonding. Sodium, what are the configurations? The previous example also, 2, 8, 1. Yes sir, how many electrons are there in the valence shell? Only 1, so 1 dot. Nitrogen, say write the configuration of nitrogen. What is the configuration? 1s2, 2s2, 2p3. 1s2, 2s2, 2p3. That means 2, 5. How many dots are there? 1, 2, 3, 4, 5, check. 5 dots. These dots doesn't indicate valency. They indicate valence electrons. Look at oxygen. Now, what is the configuration of oxygen? 2, 6. 1s2, 2s2, 2p4. How many electrons are there in the valence shell? 6 electrons, so 6 dots. 1, 2, 3, 4, 5, 6. Got the clarity? Next, chlorine. 2, 8, 7. How many dots? 7 dots. 1, 2, 3, 4, 5, 6, 7. Sir, how to represent the bonding? That we'll do in the types of chemical bonding. But what do they indicate, students? The symbol of an element surrounded by dots. What these dots indicates? Valence electrons. Neon. Neon, how many dots are there? Neon, noble gas. Don't think there are no dots. No. Neon configuration is 2, 8. How many electrons in the valence shell? 8. So 8 dots. These dots doesn't indicate valence, students. What do they indicate? Number of valence electrons. Got the clarity? Next. So what is the electronic theory of valence? So the theory which explains about the reasons behind the bondings. And the first one, the secret of stability of the atom. Like we already discussed about this point. Atoms with 8 electrons in the outermost shell, 2 in the case of hydrogen, helium, lithium and beryllium, are chemically more stable. Which elements are more stable? Atoms with 8 electrons or the elements with 2 electrons, duplet configurations and octet configurations. Reasons also we discussed. Cause of chemical reactions. The cause for the chemical reaction is to attain the stability. An atom achieves this by acquiring the octet configuration. Yes or no? In order to get that stability, do all the elements in general they have 8 electrons? No, they do not have 8 electrons. They have either 1 electron or 2 electron or 7 electron or 6. Depends upon their configuration. Yes or no? All they are reacting, why they are reacting? In order to achieve that configuration. How they are reacting? Some electrons, some elements loses electrons or gains electrons. Some elements shares electrons. Because depends upon this type of reactivity, we have types of chemical bonds also. So right, students, next, the type of electrons taking part in the chemical reaction. This point is also very, very important. For example, chlorine, atomic number is 17. Do all the 17 electrons participate in the bonding? No. Which electrons participate in the bonding, students? The electrons present in the last shell only. Those electrons are called as valence electrons. Which electrons? Valence electrons only participate in the bonding. Sir, why only valence electrons? For example, chlorine. What is the configuration? 1s2, 2s2, 2p6, 3s2, 3p5. How many shells are there? 3 shells are there. This is chlorine. Now, which electrons are more exposed to the incoming targets? This shell or the last shell? Last shell only, na? So that's why inner electrons do not participate in the bonding. Inner electrons are called as core electrons. Last shell electrons are called as valency shell electrons, and the shell is called as valency shell. You have to remember about this point. Okay, in the previous Lewis dot symbols also, what the dots indicates? Valence electrons only. And one more point, main point, valence electrons participate in the bonding is clear. Do all the valence electrons participate? Again, no. How many they require? They participate. For example, chlorine, 7 electrons are there. Do all 7 participate? No need. Chlorine needs more, how many? More 1. So 1 electron out of 7 will participate. So what is chlorine valency? 1 only. Well, it needs 1. Sodium. Sodium contains only 1 electron in the valence shell. Yes or no? It want to lose that electron. So that electron participate in the bonding. Understood? It depends upon the configuration. How much it is needed? That many electrons participate in the bonding. That is called as valency. Got the clarity? And number of all the electrons present in the valence shell are called as valence electrons. So the outermost shell is called as valence shell, and hence the electrons present in it are called as valence electrons. The number of electrons taking part in the chemical reactions are called as valency of that element. 7 electrons, 7 valence electrons are there. So what is the valency? 7? No. The electrons which participate in the bonding, that is called as, that will become the valency of that element. 7 are there. More only 1 it needs. So only 1 electron participate from chlorine. So valency is 1. Right? Got the clarity, students? So next, there are 2 ways by which the atoms can acquire noble gas configuration. This point also we discussed, how ultimately these elements are reacting. But how do they get the configurations? Either by losing or gaining or by sharing. So corresponding to the above 2 ways, there are 3 types of bonds. So based on the losing and gaining and sharing, we have the respective 3 types of bonds. One is called as electrovalent bond or ionic bonding. Second one is covalent bonding, and the third one is coordinate covalent bonding, that we are going to discuss all these types of bondings in the coming video. So in this video, we focused on the reasons behind the chemical bond formations. What are the reasons? There are already some elements which are unreactive. What is the reason for the unreactivity? Octet configurations. and the remaining elements are reacting. Why? In order to achieve that octet configuration. How? By losing, gaining, or by sharing. Understood? Got the clarity? And except helium, helium has only 2 electrons, and the surrounding elements of helium can achieve 2 electrons. That configuration is called as duplet configuration. So this is the introduction about this chapter, students, chemical bonding. I hope you got the clarity. Thank you.